Good morning, students. Myself, I am Dr. SP Yeole, HOD, Department of Chemistry, SDSM Junior College, Palghar. Students, in previous lectures, we learn about the polymer chemistry. About that, one test also given. You solve better one. Now, today I am going to start new topic, new chapter. That is unit number 7. Elements of groups 16, 17, and 18. You know about the periodic table. Periodic table consists of 18 vertical groups and 7 horizontal columns. So these are also called as periods and rows. That primary introduction you know. In periodic table, there are four blocks SPDF, that is spin, principal, diffuse, and fundamental. So these four blocks, you know how they are launched and why. So they are launched according to the electronic configuration. It depends upon the outermost electron present in which orbital, whether SPDF. As per that, these blocks are introduced or accommodated, means elements are introduced under the SPDF. So that is the primary introduction about the periodic table. In the chapter, we are going to learn about the knowledge of group 16, 17, and 18 elements. In that, the topics we are going to see, first one is introduction, next one is occurrence, then electronic configuration of the elements of group 16, 17, and 18. Later on, atomic and physical properties of the elements of group 16, 17, and 18. Now, one by one, we'll see about the introduction. You have learned in previous standard P block elements. These P block elements are differ. They has different configuration than that of the sp, s, d, and f. So here last electron is filled or enter in the p orbital of its outermost shell. That's why the elements of this one belongs to the p block. Since maximum of 6 electrons can be accommodated in p subshell, you know the capacity of this orbital. S orbital has the capacity to occupy 2 electrons. P has the 6 electrons. D has 10 electrons and F has 14 electrons. So here P subshell has the capacity to accommodate maximum of 6 electrons, and it gives rise to groups 13 to 18. In the periodic table, at start from left side we'll see elements of the S block which are of the group 1 and 2. Later on P block we'll see at the middle of the periodic table, and at last D and downside A block. The middle position we're going to discuss about the groups of 13 to 18 in the P block of the periodic table. Students, in the chapter, we're going to learn about the properties of the elements of groups 16, 17, and 18. How these elements are occur. In occurrence of these elements, first of all, we want to study about the oxygen. You know, oxygen element or atom has the 8 atomic number. Sulfur 16, selenium 34, tellurium 52, and polonium 84. They constitute or they belongs to the group 16. That's why at the top of the table in this group of 16, the first element is of oxygen. That's why selenium, tellurium, polonium, these elements are launched under the oxygen family of the group 16. Remember these things. Large number of the metal ores are oxides of the sulfides, sulfur dioxide, sulfur trioxide, like that. Group 16 elements are also called as chalcogens, or they are form elements or ore forming elements. These are called chalcogens, group 16 chalcogens. Oxygen is the most abundant of all the elements on earth. For respiration, there is much more need of oxygen. Without that, person cannot live. So it has the most important, it is most abundant element in the atmosphere. Oxygen forms 20 to 95% by the volume of air and about 46.6% by the mass of Earth crust. So it's a huge quantity which is essential to us. Oxygen occurs mainly in the combined form as sulfates such as gypsum CSO4 twice H2, Epsom salt MgSO4 7H2, barite BSO4 or barium sulfate, and sulfides like galena PbS lead sulfide, zinc blende ZnS, copper pyrite CuFeS2. So these sulfates in sulfate form it can be obtained. Selenium and tellurium are also found as metal selenides and metal tellurides in sulfide ores. The element polonium, which is radioactive, and it is the decay product of thorium and uranium. Decay product means it can be emit alpha, beta, gamma rays. So these elements are called as radioactive element. And these elements in that, what are the nucleus of these elements are highly unstable. That's why these are radioactive elements. So their decay product, polonium decay product on radiation are thorium and uranium. Remember this one. Fluorine. Fluorine atomic number 9. Chlorine atomic number 17. And bromine, it is of 35. Iodine 53 and acetylene 85. They constitute the elements of group 17. These elements are collectively called as halogens because they belongs to the halogen family. Starts from fluorine to ends up to the acetylene. All these are halogen. That's why these are the elements of halogen family. Why the halogen family? Because their outermost configuration is NH2NP5. In outermost shell, totally 7 electrons are available. So need of only 1 electron to complete the octet. That's why these are halogens you may say, and they show that type of properties. The Greek halo means salt. Gene means born. They obtain from the salt. They born from the salt. Example, chlorine. Chlorine can be obtained from the common salt. You know that common salt is sodium chloride. From that we can get the chlorine. Like that, other halogens obtained from their salt. That is salt producing element. These elements are called as salt producing elements. Later on, halogens. Halogens are very reactive elements due to their high electronegativity property. Electronegativity property means what they has tendency to attract one electron to complete their octet, means octet saturation as per the octet rule. That's why these elements are not found in the free state. Here they occur in the form of combined state or in the form of compound you may say. Just I told example sodium chloride. So chlorine does not obtain in free state. It can be obtained in the combined state with sodium like that. Other elements also obtained in the combined state in the form of their compounds. Fluorine occurs mainly as the insoluble fluorides, fluorspar, CF2, cryolite, Na3AlF6, fluoroapatite, thrice Ca3PO4 twice, CF2, fluoroapatite, and small quantities are present in soil. Fluoroapatite has the better role in making of the toothpaste. In that, it has very important role to make the coating on your teeth, which is protective from the corrosion. Freshwater plants and bones and teeth of animals, in that also this fluoroapatite obtained in the rare quantity. Sea water, you may say salty water. It contains chlorides as well as trace of the bromides and iodides of sodium, potassium, magnesium and calcium in the form of salt nature. However, these elements mainly contain NaCl 2.5% by mass. Sea water contain 2.5% sodium chloride by mass. Later on, it deposits of dried up sea beds contain sodium chloride and carnallite. has the formula KCl MgCl2 6H2O. You know, near about the seashore or wherever salt agree is areas there, in that you can observe such type of production of the salt, in that you can get the maximum content of sodium chloride with that trace amount of the carnalite also. Later on, next source is of marine life. Marine life also contains iodine in their system. For example, seaweed contain about 0.5% iodine, and chili salt peter contain about 0.2% of the sodium iodate. These are salt, but these are observed in the marine life. Later on, acetylene, last member of the halogen. This last member of this halogen family is radioactive and has the half-life of 8.1 hours as per the half-life period. The elements helium, atomic number 2, neon, atomic number 10, argon, atomic number 18, krypton, atomic number 36, and xenon, atomic number 54, and last one is the radon, atomic number 86. They constitute the group of 18 element. In the periodic table, 18 group, these are the last one, and later on we'll start the next one. In the group 18, such type of noble gases are introduced. We'll start from the helium. Helium, neon, argon, krypton, xenon, and radon. These are the elements of the these elements of the, you may say, noble gases or rare earth, or zero group element before this one is called, but we are calling that one now group 18, noble elements, rare elements. These elements are chemically inert. Why these are chemically inert? About that, you can see the octet theory. If you're going to observe their configuration, just one example I am going to tell. Suppose argon, argon atomic number 18. Its configuration is 1s2, 2s2, 2p6, 3s2, and 3p6. You may count totally 18 electrons are there. The octet also completed, like 288. If octet is completed, then they have no need to take or give electrons to others or from others. That's why chemically these elements are inert. That's why these are also called as inert gases. Right from helium to the radon, all these elements have same kind of nature. Neither they are giving or taking electron from other easily, but under drastic condition they can give or take. But under drastic condition, special condition. Come on. All the noble gases except radon, they occur in the atmosphere. Their abundance means percentage of finding in the dry air is about 1% by the volume, with argon as the major constituent. The main commercial source of helium is natural gas. Helium and neon, they are found in the minerals of the radioactive origin, means from radioactive sources. Example, pitch blende, monazite, clevite, xenon, and radon are the rarest element of the group. That's why radon is decay product of the iridium 226. Of course, iridium, when you irradiate or disintegrate, on disintegration it gives out radon. That's radon is the radioactive product of the radium. That information you have to keep in mind. Later on, condensed electronic configuration of the elements of group 16, 17, and 18. Just I told about the electronic configuration of argon. That information you can get from this table also. That is table number 7.1. It shows condensed electronic configuration. Just I told configuration of the argon is 1s to 2s to 2p6, 3s to 3p6. This configuration is the electronic configuration of the argon. But whenever this configuration, if you're going to write some short keys, some skills are adopted by certain scientists, and that skills we're going to see in the table. that skill regarding the condensed electronic configuration. What is that? One example I am going to tell. Argon configuration I said, that is 1s to 2s to 2p6 3s to 3p6. But same configuration of the argon we can write as per the table. As per the table, argon configuration of 18 we can write first of all by writing neon. Neon has the atomic number 10. So up to 10, what the 1 is to 2 is to 2 p6 is there. Instead of that, you can write neon symbol Ne in the square bracket. Later on, the rest of configuration, that is 3s2 and 3p6, that we can write. So this configuration is called as condensed electronic configuration. So this table indicates such type of condensed electronic configuration of certain element. In this table, they give information about the group 16, 17 and 18. In group 16, we'll see first. These elements are belongs to, just I told, they belongs to the oxygen family. Like that, group 17 belongs to the fluorine family, and group 18 belongs to the helium family. And their another names are group 16 oxygen family, group 17 halogen family, and group 18 inert gases. So these the names also you have to remember. Now we'll see oxygen 8, group 16, first element. Actually, oxygen 8 has the configuration 1s2, 2s2, then 2p6. So 1s2 is the plain configuration of the helium also. It has the atomic number 2. So before for writing condensed configuration, you can take the help of these inert gases. So oxygen 8 that can be symbolized by helium, later on 2s2, 2p4, like that. This configuration indicates condensed electron configuration of the oxygen. About sulfur, neon, 3s2, 3p4. Then about selenium, toluenium, polonium, you observe that their outermost shell configuration increases 4s2, 4p4, 5s2, 5p4, 6s2, 6p4, like that. And there they use the inert gases like argon, krypton, and xenon for writing condensed electronic configuration. Students, you may see the group 17 element configuration also. In that, fluorine 9. Fluorine 9 configuration, actually we can say 1s2, 2s2, 2p5. 9 is the atomic number. So 1s2, 2s2 and 2p5 is the plain configuration. But for writing condensed configuration, you have to use the helium first. In the helium, at most, helium atomic number 2, and rest of the configuration we can write 2s2, 2p6. In that 2s2, 2p6, so first of all we have to write helium, and later on we'll write 2s2, 2p6. So here this 2s2, 2p6, this indicates that the outermost configuration. Later on chlorine. In same way, chlorine, for that symbol we'll use neon, atomic number 10. Then 3s2, 3p6. Later on bromine, outermost shell 4s2, 4p5, 4p5. Iodine, iodine has the outermost shell is 5, 5p5. Later on acetylene has the 6s2 and 6p5. So in this way, their outermost configuration, if you're going to see, so that configuration we can write in the form of n number of the element, that is of ns2 np5. So ns2 np5 is the outermost general configuration for the halogen family element. Like that, for group 16, for group 16 we can say the outermost configuration is of ns2 np4. Later on, similarly we can see about the outermost configuration of the group 18. First of all, we'll discuss about the group 18 element. In group 18 element, these are also called as noble gases. In that, helium is the first noble gas, has the configuration 1s2. Later on, neon, argon, krypton, xenon, and radon. Their outermost configuration, you can see, outermost configuration of helium and actual configuration is the same. We'll start from the neon now. Its outermost configuration is 2s2, 2p6. Then argon 3s2, 3p6. Krypton 4s2, 4p6. Xenon 5s2, 5p6. Radon 6s2, 6p6. if if you're going to see the next element after radon in future, its outermost configuration is 7 is to 7p6 like that. So students, here such type of configuration, suppose for nth element number of the elements, so that's the configuration ns2 np6, which is the outermost general configuration of group 18 element, means noble gases, or you may say inert gases, or rare gases, or zero group element. Clear? As per the configuration, you can study well better. And uh, after this, we're going to discuss about the electronic configuration of the elements of groups to group 16, 17, and 18. You know, the general electronic configuration of the group 16 element, just I told, that is ns to np4, while that of group 17 is ns to np5, and group 18 is ns to np6. So if you observe that their outermost shell, in their outermost shell, one electron is gradually added, and that's why the size of the atom also increase gradually. Here, the electron has less than the stable electronic configuration of the nearest noble gas, and that's why this table shows condensed electronic configuration of the elements of group 16, 17, and 18. So this condensed configuration also you have to study very well. Later on, we are going to discuss about the atomic and physical properties of the elements of group 16, 17, and 18. In that, group 16, 17, and 18, that atomic and ionic radii. First of all, we'll see what do you mean by atomic and ionic radii. Atomic radii means it is the distance from the center of the nucleus to the outermost shell, that is the atomic radii of the atom. About the ion, it is the distance from the center of the nucleus and outermost shell of the atom. That distance is called as ionic radii. In group 16, 17, 18. So what is the effect of this atomic and ionic radii on their physical and chemical property? That we will to see in the next lecture. Till that time, everybody has to revise the slides, this PPT, or the video I sent. So study well and revise these topics. You may take help of the previous knowledge of the 11th standard also. My advice is that before starting of the study of these topics, everybody has to read the topics of periodic table from 11th standard book, previous standard. And after that, you have to start the study of these topics, what are the I said today about the group 16, 17, 18. That table, what I said, as per the electronic configuration and condensed configuration, about that also everybody has to practice. And better is that for every element of this group 16, 17, 18, first of all, you have to write the plain configuration. Just for example, I would to say, suppose neon, neon atomic number 10. Its plain configuration is 1s2, 2s2, 2p6. Now, same configuration we can write in the condensed form. How? That 1s2 that we can write by symbol the helium, and after that we can write 2s2, 2p6. So everybody has to follow this scheme. Then better you can understand about first of all writing of the electronic configuration of the element as well as condensed electronic configuration of the elements, and later on we'll discuss in detail about their properties in next lecture. Till that time, everybody take care. Thank you. Stay home, stay safe. God bless you.